Hi, everybody. Thank you for joining us today. My name is Tim Hartman. I'm the Chief Executive Officer of Government Executive Media Group, and I'll be your host for today's event. It's my pleasure to welcome you to today's program, Bringing Intelligence to Life at the Edge. This is hosted by Intel. So as the public sector undergoes digital transformations, government agencies, departments, and specific missions are ingesting more and more data. And so there's more sources of data, there's more mashups of data than ever before. So as agencies seek to harness this data explosion, how can they optimize their enterprise and mission level data flow while ensuring data security? Today, we're highlighting how edge computing can drive analytics and intelligence closer to data generation, which enables real-time insights that can transform missions, operations, and scale. So joining me for today's discussion, I have two guests. First, we have Steve Oren, who's the Chief Technology Officer at Intel Federal. Steve, thanks for joining us today.
Pleasure to be here. Thank you, Tim.
And next, we have Sean Planke. Sean is the Principal Deputy Assistant Secretary in the Office of Cybersecurity, Energy Security, and Emergency Response for the Department of Energy. Sean, thank you for joining us today. Sean, can you hear me, Sean? I think you might be on mute.
Thanks for having me. I appreciate it.
There we go. All right, so we're officially in the new world. We've had one request for unmuting. We'll keep it on your bingo cards. So before we get started with the program, I'd like to go over a few housekeeping items with the audience. To the right of your screen, you'll find several icons, including a Q&A tab. That'll allow you to ask a question. So feel free to submit those throughout the program, and I'll try to get to them as we go through. And so to start things off, we're going to ask the audience, as you join us, for a quick poll. Today, we're talking about getting real-time insights, and we want to have a better understanding of where everybody stands currently. So we can launch the poll now. Overall, the question is, overall, how would you rate your experience accessing information on your organization's network? Evaluate based on your ability to rapidly access information, how you want, when you want, and where you want. So your choices are broken, poor, average, good, or excellent. I'll give everybody a minute to answer the question. I know I have my suspicions of where we'll end up here, but it'll be interesting to see as a starting point for us to have the conversation, just where everybody in the audience is. All right, so I think we can see the results now. Polls closed, but I can't see the results yet. Here we go. So the results are, most people said that they were, in a good or excellent place. Many were average, and then about 6% said it's completely broken or poor. So we got people who are, along the continuum here, and overall, we'll dive more into these results as we go through. So that's a good transition to Steve Oren, who's going to give us a presentation. Steve's the Chief Technology Officer of Intel Federal, which I mentioned earlier. He's going to talk a little bit about the state of data in the government space. Steve, take it away.
Thank you. Second here. There we go. So I want to talk today about bringing intelligence to life with your data from the edge to the cloud. So before we get started, let's start with understanding what we're talking about. What is edge computing? And really, it's a combination of things, but at its fundamental core, it's the movement and transitioning of compute resources to the edge, to the point of data creation, to the point of decision, and really moving a lot of the compute and the capabilities for inferencing and intelligence making all the way out to the edge, to the place where your sensors, your devices, and your people exist and live. Now, it doesn't mean you have to throw away your data center and your on-prem clouds and your public clouds. It's all about leveraging the right compute in the right place for the right function. What are some of the things that are driving this need for edge computing? Well, we know that that network bottlenecks and latency have been a big deal when trying to collect all this data from the vast amount of sensors and devices that are generating what we're seeing as growing to 175 zettabytes of data being collected and generated. And so the bottlenecks for the network, the latency, but also the costs associated with moving and storing all that data. And at the end of the day, it's the lack of actionable insight. How do you get intelligence out of the data quickly and into the hands of the people that need it most? And this is not going to stop, as we see from these reports, whether it be from Gartner or from IDC, the amount of data and the amount of devices that are connecting to our networks is continuing to grow. The other thing is this really interesting one at the top from Information Week, that of all the data that's being collected, they believe only about a single-digit % of that data is actually being processed into something useful. And that just means we have a lot of wasted data. So how do we move more capability to where that data is so that we can get more value out of it? When we focus in on the public sector and government, there are a variety of places where edge computing exists today and will continue to evolve and grow, whether it be ruggedized devices and systems in the field, to tactical command centers, signal processing, the growth in unmanned systems, vehicle electronics, really the instrumentation of everything that's in the battlefield or in the agency deployed into the field, whether that be for DoD kind of use cases to even interior and forestry, where they need to sensorize the national forest to be able to keep track of their health and well-being. These are all use cases that are driving edge computing and trying to give insights and situational awareness to the mission and to the enterprise. But of course, there are challenges here, as well as opportunities. Oftentimes we see when you start doing edge computing and you start moving capability, you have the impacts of data silos, where you get little bits of information around the different sensors that you're collecting. And that means we need to do more than just push all of our compute to the edge again. We need to coordinate from the edge to the cloud and across different edge sensor environments to get that data fusion and that sensor fusion, to break down those silos. What we also can't do is implement a fragmented security approach. We need comprehensive security from the edge to the cloud, and make sure that we're applying those security controls that are appropriate for the environment, whether you be at the edge with its unique requirements or in the cloud or data center. One thing that edge computing does help with is the areas around data regulation, especially around data sovereignty or specific controls that you need to put in place where that data happens to exist. And being able to apply those security controls and those compliance controls at the point of data acquisition and data generation allows you to more quickly and easily meet those compliance requirements. And we have to recognize that this is going to make things a little bit more complex on the management side. More devices means more nodes that have to be managed and controlled. Intel's approach to turning data into action is really a three-pronged approach. Its foundation is bringing the right capabilities of compute, storage, and network to all stages of the data lifecycle, from the edge to the data center and cloud and back again. But to overlay on top of that, cohesive management for those devices and for your data as it moves through the system, and comprehensive security up and down the stack. And tying all three of those together to help the mission and enterprise really deploy the best out of what their infrastructure and applications are trying to do. Specifically in public sector, Intel is powering the sensing and inferencing that happens at the very pointy edge of the spear with analytics and AI at the edge, and then the ability to pull that together into what's sometimes referred to as the fog network, to be able to do analytics and prediction in more centralized or tactical environments, and then of course be able to then move the important information that and decisions up the stack to the cloud and data center with the ability to do that feedback learning all the way back into the edge. And so being able to provide that end-to-end capability of data processing, storage, and transport for all parts of the lifecycle from the edge to the cloud. The way we've done this is with a combination of technologies. Our core processing platforms optimized for the different kinds of environments, whether it be performance versus power, from the Atom all the way to the Xeon, as well as innovative AI and accelerator technologies like our visual processing units and FPGA components. And then the foundational technologies that are just as important around being able to move and store data at speed and get real-time analytics, from our persistent memory with Optane data center persistent memory to our silicon photonics and Ethernet controllers to really give you the best network performance at the edge all the way to the cloud. Because at the end of the day, you need to be able to process, compute, store, and move your data at speed to get the right situational awareness into all parts of your data enterprise and mission. But ultimately, we know that this isn't something we're going to do alone. And so Intel creates and works with large ecosystems to provide these ingredients and these solution stacks to the marketplace. So bringing these innovations, these ingredients to the system to providers and makers, these are the OEMs and ODMs and these software ISVs, working together today with over 500 IoT and edge leaders, working with the system integrator and federal contractor community. We have already published over 6,000 solutions together with that ecosystem to help the government, aerospace, and defense industrial complex to meet their mission and enterprise needs for edge to cloud computing. So with that, I'll turn it back over to you, Tim. Thank you.
That's great. Thank you, Steve. And we'll get into the group discussion now. So Sean, you can unmute yourself now as well, as we'll all have the panel discussion. Sean, before we start, we've got Sean here from the Department of Energy, and he's joining us from a facility that would not allow video. So we'll just hear our voices from this point. Oh, there's a good picture of us. Sean, why don't you give us a little bit of background on your role at Department of Energy and what you're involved in?
Sure. So at DOE, I'm the Principal Deputy Assistant Secretary in CSER. And so basically what that means is we are the sector-specific agency role. So, and you can find that under Presidential Policy Directive 21. That basically means we're the interface for the private sector. So we're working with the private sector to develop better security models, physical and cyber security. And then we're also the emergency response function. And what I mean by that is we work through FEMA. When FEMA activates, we activate under ESF 12 to respond and get power, critical infrastructure back online for people, for hospitals, for first responders. So what does that mean in this context of digital transformation and edge computing? This office has about a $70 million a year R&D effort, research and development through the national labs and through universities across the United States to basically say how do we use technology to advance security and advance resiliency. So right now, in particular, from this edge-based perspective, we're thinking about in the oil and gas community, right? Offshore oil platforms, fracking sites have massive amounts of data sets, data collection points. We're saying, how can we provide security at those edge points? My counterpart talked a little bit about what Intel was doing in this space, but basically, how do we aggregate and understand adversaries at each layer from the edge all the way back up to the cloud or the major data center that you have. So that's in particular a direct perspective of what we're trying to do here at CSER.
That's a big job. So tell us a little bit more about how you're approaching that problem. It's obviously, I think what Steve was presenting was just a dynamic landscape where as we move to the cloud and we move to more a wider edge, basically a wider perimeter, there's much more complexity, I imagine, in this. So tell us a little bit about how you're approaching that, Sean.
Sure. So on the security side, from the get-go, we have to sit back and say, hey, we probably, when energy systems were designed, we probably didn't think about security at the time. It was more, how do we get power? How do we get power fast? Or how do we harness, resources to provide energy generation to people? And so now we're trying to sit back and say, we know that our nation state adversaries, China and Russia in particular, are going after our critical energy infrastructure, right? The Director of National Intelligence has said it twice now, in 2018 and 2019, that they are going after oil and natural gas and also the electric grid. So we're saying, hey, how do we understand what the consequence of what that looks like? People, when they think about a security incident, always go directly to the incident, and they don't think about necessarily the second and third order effect that happens after that. The incident occurs, but if you're a nation state's trying to think more of a strategic game, and they're thinking about what happens after that and what happens subsequently after that, so second and third order. We have a program called Consequence-Driven Cyber-Informed Engineering through Idaho National Labs, and that basically looks at the most severe consequences that could happen from a security perspective, albeit physical or cyber, at a site, and then say, how do we back that up and look at, through process design and protection decisions, can we isolate an adversary so that the desired end consequence can never actually manifest? And so, so that's where we start. That's Genesis. That's part number one. Then we bring in, how do we provide capability to do that, to identify that? So right now we have a program called CAT, Cyber Analytics Tools and Techniques. And basically what that does is it looks at data sets, and it says, how can we identify targets or tactics and techniques that an adversary might do, and put that and mesh that against what our private sector partners are seeing. So if a private sector partner comes in, shares their information with us, we can provide an anonymization of it, and then they can compare it to anomalies that may occur that adversaries are using as their tactics, techniques, and procedures in systems, and bring it back to their site and say, hey, that's an adversarial activity. We should investigate that further. Does that make sense?
Yeah, no, that's great. So Steve, chime in here. Is this, what do you see in this type of framework that Sean is discussing here as some of the challenges and opportunities, for some of the technologies you discussed?
There are a couple ways to look at it. I think when we look at trying to secure these edge systems, there's sort of two almost competing forces. One is this notion of, how do we bridge the security controls from the data center out to the edge? Really, how do we use IT security to help augment OT security and edge security? And the other is recognizing that edge security isn't like your data center. You don't necessarily have guards with guns and buildings to protect. These are remote systems, and oftentimes in places that are not easily accessible by physical human support. And they have to be long-lived, ruggedized, and able to protect themselves from both digital and physical-based attacks. Those security properties are not the same as what you find inside a cloud data center. And so making sure that you're engineering your edge security solutions to take advantage of hardware and software security capabilities that are optimized and designed for edge use cases, whether that be a combination of things like secure boot technologies and trusted storage, to the ability to encrypt and control data at motion, at rest, and in use, are all properties that you need to bring to bear. When we work with our customers in our ecosystem in designing these edge to cloud kind of use cases, we look at it for, how do you protect the data throughout its life cycle? Make sure you have the right protections where you're doing the where the data lives at that moment, and for it to transverse the whole network. And so that goes exactly what Sean is talking about. We have to think differently when we look at, how do we protect the edge systems. especially when we look at things like in energy, where you have that cyber physical attack and cyber physical damage. This is a lot worse than just taking over a camera. We're talking about taking over generators or power grids. You want to make sure that you're providing the right level of security to prevent those kind of attacks and threats.
Yeah, that's exactly where I'm going. And I want to add to that, and we think about, we have to recognize that in the energy community, that goes cross-border, right? So we have, there are pipelines that go across from Canada to the United States. The same with Mexico to the United States, right? So we have cross-border cyber physical systems. So there's different, there might be different security postures, different threat vectors, different standards. So when we're pushing that security all the way out to the edge, we have to be cognizant of that it may need to operate independently, and it may have other barriers that we haven't thought about because we're not operating from a single central point.
Yeah, that brings up a good point. Even beyond the edge, right? We've got cloud, the Internet of Things, 5G, and artificial intelligence taking an increasingly prominent place in the federal government's IT strategy. And so we've seen more data live outside of the traditional network perimeter because of that. So Sean, how does this impact your overall security posture?
That's a great question. There's obviously a number of trends and developments for everything from connected cars and battery storage, smart cities, home automation, all that sort of upcoming technology that is beyond the traditional perimeter. One of the things we think about is we think of distributed or small electric carriers that are located throughout the United States, and the potential for IoT devices, whether it be a consumer IoT device or a purposeful energy-driven IoT device. That connectivity and that data collection point and potentially injection point for adversarial activity is something that requires a next generation edge security model. And that's when I do actually like to think about the AI piece of it. Can we take, knowing that you have autonomous, or knowing that you have injection points out at that perimeter that may be isolated, that may be alone, and they actually may not be connected back to your central hub due to the remote isolation of the network. Can you have autonomous security at those endpoints that has an ability to self-shut down, self-regulate, or even self-defend without support from your central point? At least enough to throw up what we would call in my military service days a red star cluster, so that your main hub could say, hey, something is not going right at that site. That this endpoint may not be able to defend against it long term, but it has an AI capacity strong enough to throw that star cluster or shut itself down, or put a perimeter or even encryption around your data set that would protect it for a period of time until the rest of the cavalry could arrive.
Yeah, that's fascinating. Steve, you're kind of on the cutting edge of thinking about a lot of this stuff, I'm sure. I mean, what are you seeing as a developing model for dealing with this?
Yeah, and I think Sean brings up an interesting point. There's a lot of interest right now about how to leverage AI and machine learning and apply it to the cybersecurity domain, both in the cloud and at the edge. And there are sort of a variety of trends that are driving that. Both the intelligence that you now have in these edge devices makes them obviously a rich target, but it also means for the first time you have the telemetry and the capability at the edge to actually perform some of those functions. So when you think about deploying an AI at the mobile edge computing side, or out at even into the sensor side, having the instrumentation and the telemetry on those devices so that you can read the information, see how the node is operating, check the bits, be able to verify the firmware and do attestation so that you can actually monitor those devices and be able to determine what is anomalous behavior, what is just normal within range, and be able to either report that back in or implement security controls and thresholding on demand. So we're seeing a lot of that innovation on the AI and model building side, but we're also seeing that the edge itself is gaining that compute capability to be able to defend, be more helpful in defending itself and implement the security controls that you'd expect to have there, whether it be being able to do secure storage with tamper protections or be able to do encryption on demand for data and authentication of the device to the broader network. So we're seeing this convergence of sort of powerful edge capabilities with the AI and machine learning to be able to take advantage of that. We're also starting to see interesting models being built to look at sort of these autonomous nodes and how do you tell when there are, there are terms like Byzantine General or other style network collusion attacks occurring. We're seeing a lot of research right now into the AI models to be able to detect those subtle anomalies and be able to report on them. So there's a lot of innovation happening here right now.
So yeah, agencies are collecting more data than ever right now, and that means they also have to manage the movement of the data, which we've talked a little bit about. But that data, can be incredibly costly and complex, especially as it starts to strain your network. And where does edge computing fit into the ecosystem and help mitigate some of those costs?
I think that is one of the things, as we talked about in the presentation, that edge computing really helps you do. At the end of the day, you really don't need all of the raw data. And I think the best example of this is if you think about video surveillance or a video camera watching a certain area. You don't care that nothing has happened for 12 hours. You care that something moved for those 20 minutes that it detected. And so combining that edge inferencing to be able to do object detection and change detection, and only record the important bits that you need of what happened, what occurred, and maybe the 10 seconds before and the 10 seconds after, you're doing a data minimalization. So first thing you're doing is you're reducing the amount of data that you have to store and forward. You're also getting actionable intelligence. You're saying something has happened, and even being able to do AI object recognition to say, okay, that was a cat moving across the lawn, or that was a person trying to break in the door. And then being able to provide that rich context back to the back end to be able to make a decision, set off the alarm, or send the cavalry, as Sean mentioned. And so being able to do those things at the edge reduces the need to store and transmit all of that data. It also gives you quicker time to decision, quicker time to having relevant intelligence and situational awareness. You may not need the cloud to be involved. If you see a recognition of an event, you can already have policies in place to send up the alarm, to lock the door, or to do the action without having to wait for the cloud to respond back with what it found out. And so what we're seeing is edge computing is really pushing decision-making, sense-making, and intelligence all the way to the edge so that you can make real-time decisions and get situational awareness at the time of when you need it, as opposed to waiting on the latency, while at the same time reducing the complexity and cost associated with moving that data around the network.
Sean, what are you looking for here? You mentioned this a similar framework for thinking about this, where you talked about the getting the signal from the edge that something is wrong, but not necessarily needing the data all the time. Tell us more about that.
Yeah. So in particular, what I think Steve's example was actually great, and it made me think of Amazon and their Ring cameras. I mean, they've just recently moved to that model for human sensing, so they can save battery charge on recording, which I thought was great. And it's also a great example of the cyber-physical interplay, right? Cybersecurity and physical security working together holistically. But when we think of this this ecosystem and what are we doing in DOE, we're trying to devise systems and fund the research and development on R&D that has that endpoint analytic capability that can sit next to, let's say, a sensor, right, or a PLC in our industry, right, a programmable logic controller, right. So how do we push that all the way out so that the remote site sensor, where there's only a few of these things, they're not traditionally made for security, can understand if it's getting an anomalous reading, right? So can we push that security model all the way down to the sensor that is looking at temperature, or the sensor that's looking at flow rates in a pipe, right? And understand when something goes wrong. So if you think about what happened to, Stuxnet, the study behind Stuxnet was that the centrifuges in Iran were spinning out of control, but the sensors were reporting that they were spinning normally. Can we push that autonomous edge computing out to sit next to that sensor and provide us a security posture all the way down to that edge?
Yeah, Sean, that brings up a good question. At Caesar, you have a focus on identifying and mitigating new threats that come with the growing Internet of Things universe. So what are your office's big priorities on IoT security?
So our big priorities that we're paying attention to, mostly, and the number one right now is supply chain security. I think you've probably heard that of the bulk power executive order that came out. Well, that bulk power EO, one of the key components of it is a program that we have called Citrix. Citrix is cyber resilience testing for industrial control system, and that basically is looking for vulnerabilities, both physical and vulnerabilities in the firmware of programs in the energy sector. If you and Steve, you probably can take this even further, but if you look at how firmware and software in general is written these days, it's nobody's baking from scratch anymore. Nobody's making mom's cookies from scratch. Everybody's buying the package at the store that's pre-made. And it's the same in software. People are taking code libraries that are created elsewhere and that have been around for years, and they're repurposing them, relinking them, and using that as the basis for their code. And they're probably in many cases today not even writing at that level, right? They're writing higher up, like at the application level, and they don't even realize that they may be taking, firmware code or lower level code examples from other devices because it's already baked in. I mean, if you look at VPN filter years ago that used the same code across multiple chipsets for SOHO routers, Ripple 20 that came out a few weeks ago is another example of common vulnerabilities that have been around for years, and people don't even know that they're pulling from these code-based libraries that are using this old software code.
That brings up a really good point. If you look at the research and the exploits from the last several years of IoT devices, there's a common kill chain, a common set of steps that the adversary or the researcher does. They find some vulnerability in the code of the device. They create an exploit and deploy it, swap out the firmware with malicious code, and then do bad thing with the device. Every time it's that same flow. And the last step in that kill chain always is swap out the firmware with their own vulnerable or malicious code. And so to Sean's point, we've got to do a better job of both the supply chain of the software and firmware that goes into these devices. But we also should be taking advantage of features to make sure that we are validating the firmware when we load the system. So signed firmware, secure and attested boot of that firmware, so we can verify the firmware prior to allowing that sensor to connect to the network or accepting data. And these are fundamental, sort of hygiene that oftentimes gets overlooked in a lot of IoT devices that need to be enforced throughout the supply chain.
Yeah, and I think, to take Sean's metaphor, maybe in the COVID era, we'll start seeing people coding from the ground up just because they're bored, just like everyone started baking cookies from scratch again. It's the developers are going to go back to coding from COBOL. We have an audience question here, and we'll ask this question, then we'll move on to another audience poll. So first question is, how am I going to link my edge decisions to my AI database? Steve, do you have a sense of how that architecture is going to work?
Sure. So there's a couple ways of looking at this. A lot of times what you'll do is you start with your training and your model creation using your cloud or data center resources or already pre-populated model zoos. And then you deploy that model into the edge and do what we call edge inferencing. But that's sort of a simple way of looking at the world. The reality is a lot of times we're doing what's called feedback learning. So we deploy our inferencing AI models and algorithms to edge sensors and edge compute platforms. But we're also doing feedback learning to help enhance those models with real data and real decisions with that feedback loop. And so it's not a one or the other approach. If you look at the overall AI lifecycle, machine learning lifecycle, there's this feedback that you see between the data center where you're training your model on large swaths of data and events and deploying those models to the edge to make real-time decisions, and then feeding those decisions back into the AI to better train your models. And so that separation that we classically see in the reference architectures of training on the back end and inferencing at the edge, it's not so simple. There's a lot of back and forth between both of those. But that's really the architecture we see most people deploying, is that edge inferencing with that feedback learning loop to help drive better AI as you start to see real data. And you can see this in play in things like your Tesla and other autonomous vehicles have edge inferencing to tell you that that's a car that you're about to turn into right now, but they're also connecting to the cloud to be able to gain the better AI and to be able to tell it that I made these decisions today and be able to make better decisions tomorrow.
That's fascinating.
And I'd like to say, on top of that, the other thing they're pushing back and forth, right? I understand, to speak to the Tesla model in particular, I know what a road is. I know there should be left and right, limits here, right? There's a yellow line on one side, there's white lines on the other, and it has different basic sensor capabilities. But you remember that the Tesla is sending the GPS position at the same time, right? So when you get that GPS, you can realize, abnormally sharp turn here, and it can marker it, and then it helps for the greater good. And that's actually one of the principles a lot of security companies are going to. They're saying, hey, we can do this autonomously on our own, but when we recognize something that's unique to this in this case, we're talking Tesla, so geolocation, I can send that back so that other users may benefit as well.
Absolutely.
Yeah, that's a great point. Let's move on to the next audience poll. So if we get the audience poll up here you'll see it here. It says, what reasons, if any, are motivating your organization to expand computing power at the edge? Select all that apply. Lay the groundwork for emerging tech, which we've talked a lot about today, growing trends in workforce mobility, ability to scale mission requirements, boost collaborative capability, to improve situational awareness, or to increase service accessibility and public outreach. So we'll give everybody a minute to answer that, and then we'll review the results with our panel here. A few more seconds here, and all right, let's see the results. So we got, waiting for the poll questions to come up here, and we'll see. Oh, here we go. So the most popular answer of the respondents was lay the groundwork for emerging technologies, AI analytics, 5G, Internet of Things. And the second one is improve situational awareness. So does this surprise you, Steve, at all? I mean, it seems like this is an emerging tech crowd that we have in this event.
It doesn't surprise me. I think that the two that I would have said would have been improving situational awareness, which really gets to doing something with the technology at the edge. And what a lot of organizations are sort of that stage right now, which is sort of laying that groundwork, getting the foundations in place so that they can then get that benefit. I think going back to the original poll, you see that a lot of people are still in that early or mid stage of getting their edge computing up and running. And so whether that be 5G or AI inferencing, got to build those foundations so that you can then do things like situational awareness, collaboration, and scale mission requirements. But it doesn't surprise me.
And so, we're almost at time here. So as we wrap up, I'd just like you guys to maybe share a few practical takeaways with the audience. So, Steve, what's your biggest piece of advice for agencies looking to harness edge computing to get and enable real-time insights?
So I think my best advice is get started. Go off and do pilots. There are plenty of models and reference architectures out there today. You don't need to go reinvent the wheel. You don't need to bring in 1,000 data scientists to solve your particular problem. We don't need to reinvent the wheel. We can actually go and deploy a lot of these things. And once you start deploying it, you'll start to learn what are the things you need to do to tune and enhance the mission, whether it be enhance the AI models you're using, get better connectivity for the edge solutions, upgrade to 5G for machine-to-machine communications, and make sure that you get your security right on those pilot projects. Oftentimes perfection is the enemy of good, and we need to get things started because we can't wait. We need to start to take advantage of these technologies so that we can get those benefits of being able to get mission awareness, sensor fusion, and coordination and real-time tasking. To be able to enable that, you need to get an infrastructure in place. And so like I said in the poll, laying that groundwork, get started is my best piece of advice. And make sure that you apply the right security controls from the beginning, because as we've always learned with every new technology, you can't bolt on security. So you've got to lay that foundation down from the get-go. And if you do those two things together, you'll set yourself up for success in the next wave of technology evolution.
Sean, from your perspective, what should agencies do to ensure their data is secure at the edge? What's your final thoughts?
First, I'm not sure that I want to do a panel with Steve again. He steals all the good stuff. Great point, Steve. What I would go to is I go to my intelligence background, right, from the Intel community, and I'd like to understand the threatscape. What I mean by that is a lot of times I find that people build towards vulnerability and not towards threat actor. People say, oh my gosh, like a physical perspective, they spend all their money on the height of the fence and they don't realize that they're going against people that are going to tunnel under it, right? So if you're building your system, look at what adversaries are most likely to attack you. What are their standard tactics, techniques, and procedures to do that? How are they evolving? How can we think like that adversary? And then let's spend our money to build to those specifications, right? As opposed to broad brush saying all vulnerabilities are equal, because all vulnerabilities are not equal. If you're building against a vulnerability and spending your money on something that your adversary just goes around, well then you haven't really done yourself any favors. So I always like to say, well, what does that adversarial actor look like from a security perspective, and then build to defend against that. That would be my advice.
Well, I just want, as we wrap up here, I just want to thank you both for joining us today. I want to thank Sean Planke from Department of Energy and Steve Oren from Intel Federal for some great insights on the landscape as we look at a really dynamic time with emerging technologies and data proliferation and the opportunities with AI and other things. I think we covered the full landscape of emerging tech here. So that concludes our program. And I'd like to thank, on behalf of Intel, I'd like to thank our audience for tuning in. Today's program will be available to watch on demand and share with your colleagues soon, so keep an eye out for links that you can share to that. And I hope everybody has a great day. Thank you for joining us.